Come on, solve this question now. So good, but there is a purpose why I gave this question. So everyone concentrate. I'm going to explain this because you're going to learn something important. Everyone concentrate. Okay. So whenever, you guys remember we did in the past when we had to compare two fractions, something like A by B and C by D. If we were to compare any two fractions, does anyone remember I taught you two different methods?
Yes, sir.
Alternate and inverted.
Calcium method, and the second one. Okay, Ronak can say the second one.
Yeah, Ronak, what's the second one?
The alternando and invertendo.
No, right, kind of. Okay, so I'll quickly revise for people who if you remember, we did problems like this, something like we need to decide 7 by 13 and say let's take 4 by 9. So we want to decide which one is greater. So one method that we know is, we make the denominator same. Therefore, I multiply this with 9, multiply this with 9. We multiply this with 13 and this also with 13, and we try to get the factors. Your denominator is same. 9 into 13, I need not even calculate. So 9 sevens are 63 divided by some monkey here, and this also 4 13s is 13 fours will be 52 divided by the same monkey out there. So we know that this monkey is bigger, therefore this fraction is bigger, therefore 7 by 13 is bigger, right? So this is one method. The same method, this is the regular, the way you are supposed to do in a school, in your actual school preparation or school exams. Now, the same thing that we learned the other way around, 7 by 13 and 4 by 9, the same thing I taught you, wherein because we know the denominators are going to become same, the only thing that's happening is this 9 is actually getting multiplied here. 9 sevens are 63, and this 13 is actually getting multiplied there. 13 fours is 52. Therefore, we say that 63 is greater than 52. In actual terms,
looking at cheeky shortcut, maybe you can use in like Olympiads and stuff. I'm not so sure about schools.
you mean the second method?
Yes, sir.
Yeah, but if you look at second method and first method, actually are the same methods, but
So
written.
it is same, but the only thing is that there you're not calculating the denominator, and here you're actually are calculating the denominator, and in like exams and stuff, you actually have to show the denominator.
Correct. Absolutely. So the reason I'm doing that, I put a monkey there is just to let you know that whatever the monkey in the denominator doesn't matter, right? In deciding the fractions, right? Which fraction is greater. So that is something that I want you to take home from this method that we learned in the past. I just revised it. Now let's come back to this question. Now the reason why I'm giving this question is this is an easy one. You're going to get tough questions like this, very tough questions on radicals. When you have radicals instead of powers like this, exponents and powers like this, when you have radicals like, they'll ask you what is the cubed root of 5 and 4th root of 7 and 9th root of or 5th root of 11. They'll ask you which one is greater, something like that. Now, when you get questions like that, you need to understand how do we approach such questions. Okay, so let's concentrate, everyone. So when I'm teaching, I gave you a simple example. When you look at this, you will obviously, the way Arya did 2 power 6, he calculated, he said it is 64, 3 power 4 is 81, and 4 power 3, 4 fours are 16, 16 fours are 64, and 6 square is 36. Clearly, 81 is greater. So all of you might have decided that 3 power 4 is the greatest exponent here. Among the given numbers, 3 power 4 is the greatest or the largest number. Now, the point is not this particular question. I wanted to teach you concepts. So concentrate. 2 power 6, 3 power 4, 4 power 3, and 6 square. So whenever you have powers like this, the best way to solve these questions is get all the numbers to the same power. Say, for example, if I raise this to the power 2, this will be how much? 2. So
12.
basically 12. So why did I do that? Sorry, I just skipped a step. Everyone concentrate.
Yes.
Okay, so let me come back now. So 6, 4, 3, and 2. So there, if you look at all the powers, right? 6, 4, 3, and 2. So are they common powers?
They are common, but they're not like the same.
Correct.
Sir, you are trying to make the powers same and then you will compare the bases.
Correct. That's
So
the way to
2 to
do.
the power of 6 can be 4 to the power of 3. 3 to the power of 4 can be like can be, I guess, 27 to the, not 27, but
Okay.
yeah, it can be 9 to the power of 9 to the power of 3, which 9 to the power of 3, I think. Yeah. No, 9 to the power of 2. Sorry.
Okay. Okay. Don't worry. So let's observe few things very clearly. We will come to this 3 power 4 little later. Just give me a second and observe this. Now, basically 4 power 3, 6 square, 2 power 6. Now, let me write this 2 power 6. Let me write this 2 power 6 as 2 power 3 whole square. Can I write it that way? Can I write 2 power 3 whole square? Can I write? Yes,
Yes,
very
sir.
good. Yes. Now, can I write 3 power 4 as 3 square whole square?
Yes, sir.
And
Yes, sir.
now 4 power 3, I can actually write it as 2 square whole power 3. In the next step, I'll change that. Don't worry. 2 square whole power 3. And I'm keeping 6 square as 6 square only. Now, just observe this. 2 power 3 whole square. This is 8 square. 3 square whole square. 3 square is 9 whole square. Now this 2 square whole cube, I can interchange it and write it as 2 cube. I can write it as 2 cube whole square. And 6 square, I'll keep it as 6 square only. So now every number is in the form of square. So now I just need to look at bases. This is 8, this is 9, this is 2 cube, which is 8, and this is 6. Now when I compare all this is greater, therefore this is greater.